Hi everyone. So we're going to take a look at graphing quadratic equations in standard form. And to do this, first let me intro with real-world application. Okay, this is going to be a stretch. When my wife was pregnant with our second child, 9 months pregnant, she was huge with him, all right? I mean, and she waddled quite a bit with him because he was so big inside her. And my wife's not very tall. And there was these kids that would walk home past our house every day from school, and they kept ringing the doorbell and then running. Okay, so I came up with a devious plan. I was really worked up about this, you know, me being going to be a new dad and sort of thing. I came up with this plan. So this would be our house right here, and there's these bushes, and one kid would hide behind the bush while one other kid would ring the doorbell, and then they'd bolt down the sidewalk and then turn the corner at the end of the street. So the idea I came up with was to rig a catapult on top of my house and then rig a wire to the doorbell so that as soon as the doorbell rang, this catapult would launch a water balloon, all right? And I calculated it so that these guys would turn the corner right when they think they're safe and they're turning the corner, bam! The water balloons would take them out. There you go, real world application. Did I ever carry it out? Nah, because I was too lazy, I guess. But the point being, there is some real world application to this sort of thing. I use this sort of equation to figure this out. And if you stick with me all the way through these, I'll show you how to work these kind of problems using a free fall or even initial velocity type situation, all right? But first, let's graph this guy. Now, this is going to be a longer video, just so you know. I've already spent 2 minutes on this talking about my little devious plan there, so I'm dedicating it to my crazy brain, I guess. I don't know. Okay, the first thing I'm going to look for here is the y-intercept. Okay, that's going to be the easiest thing to do. It's going to be 0, negative 5. That negative 5. Because what's happening is f of x is the same thing as y, essentially, right? So if you plug in a 0 for your x values, this term goes to 0, this term goes to 0. All that's left is the negative 5, right? So y equals negative 5. So there's your y-intercept. Let me graph this as I go, okay? So you put down a Cartesian coordinate graph here. Coordinate plane, excuse me. 0, negative 5. 1, 2, 3, 4, 5. I'm right there. Okay. Now we need to figure out how this thing is going to open. Will it open up or will it open down? It's going to open up. Okay, and how you know that is because your leading coefficient is positive there. Okay, if there was a negative sign right there, then my parabola would have been upside down. But right now my parabola is going to be right side up. Okay, now let's find the vertex. But before I even find that, I'm going to find what's called the axis of symmetry. And for that, let me take a look at a little friend of ours first. Do you remember a quadratic formula? Looks like this. So if you want to memorize the x-coordinate of the vertex, or I guess the axis of symmetry formula, vertex formula, whatever you want to call it, it's this piece right there. Okay? Yeah, that's what I'm going to use. So let me erase the rest of this stuff. So if you know the quadratic formula, and you know where to look for the vertex formula, it's pretty handy. So there it is. So my leading coefficients here are 1, right? I'm going to call that A. My negative 4 is B, and my negative 5 is C. So the negative of B, so the negative of negative 4 over 2 times A. So 2 times 1. Well, let's see, that's 4 over 2, which is 2. So my axis of symmetry is x equals 2. Don't just say 2 because that doesn't tell you anything. Axis of symmetry is going to be an equation, okay? So, and it's usually going to be x equals something if it's a vertical axis of symmetry, or y equals something if it's a horizontal axis of symmetry, which I'm not going to get into here. So axis of symmetry is x equals 2. It's a vertical line that goes like this. And what that means is half my parabola is going to be on the left side of this vertical line, and half my parabola is going to be on the right side of it, okay? That's why they call it symmetry, the axis of symmetry. It's symmetric on either side of that dotted line. All right, now let's find the vertex. The vertex, in this case, it's going to be the lowest point of my graph, okay? If it was an upside down parabola, it would have been the highest point. But it's right side up, so it's going to be my lowest point. I've already got my x-coordinate. Let's go find the y-coordinate. So what I'm going to do is I'm going to plug in a 2 for my x. And I got 2 squared minus 4 times 2 minus 5. Let's see, that's 4 minus 8 minus 5. That's what, -4, -9? Okay, so my vertex then is going to be the 2, comma, -9. Okay, that's my vertex. So let me plot that. So I've got 2, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm right on that axis of symmetry. Okay, that's my vertex. So that's going to be my low point. So, a couple things here. First of all, remember this guy? That's our y-intercept. Let's find out how many horizontal units it was to get from that point to my vertical line, to my axis of symmetry. 1, 2, right? So if I go an additional 2 units to the right, 1, 2, that guy is going to be on my parabola. Okay, so my parabola is going to be going down through this. It's going to do this sort of thing. Okay, now the last thing we're going to take a look at are my x-intercepts. And out of all of this, in my opinion, finding the x-intercepts is the hardest part, once you know how to do some of these things. So I'll go x-intercept with possibly an s. So I could have 1, I could have 2, I could have none x-intercepts. Based on the shape we're seeing here, it looks like I'm going to have 2 of them, because the x-intercept is where it crosses the x-axis here. So it looks like it's going to cross somewhere over here, and then again somewhere over here. But how do we find out exactly what that is? Well, I remember back when we did the y-intercept and we set x equal to 0 and found the y. Now we'll do the exact opposite. We'll set y equal to 0, and we'll find x. Like that. It's a matter of factoring, and that one might be slowing us down a little bit, but this one isn't too bad. You won't always be able to factor. Sometimes you'll have to use like the quadratic formula and get 2 irrational x-intercepts, and those speak. They're not much fun. Okay, so I solved for x. I got x equals 5 and x equals -1. Hopefully, as I talked, I didn't really talk about what I did here, but hopefully that makes sense as to what I did. Now, those guys are just x values, okay? Those are not the x-intercepts. The x-intercepts are 5, 0, and -1, 0. Okay, those are my x-intercepts. -1, 0, and 1, 2, 3, 4, 5, 0. As I do these, I like to plot these points as I go, because it helps me figure out if I'm on the right track. For example, if I got my x-intercepts and they were like way out of whack, I would have said, okay, something's wrong. Either my vertex is wrong, my x-intercepts are wrong, or my y-intercepts wrong. So that's why I like to plot as I go, so I can figure out what I'm doing. Okay, like I said, this thing took forever because there's like the y-intercept. How does it open? Axis of symmetry, vertex, x-intercepts. There's a lot going on there, and this video is already 9 minutes long, so I'm just going to shut up and call it good. Okay, stick around. I'll do another one.